Okay, so the way a pendulum swings, and this is physics, models a geometric sequence, and pendulums are like pretty important in the world of science. Some pendulums are important in mechanical engineering. They keep things moving, the way pendulums swing, and then one of the most important modern day uses of a pendulum is they put them on the top of skyscrapers, and it helps balance the swaying of the skyscraper. So some of our tallest buildings have these huge pendulums on top, and when they sway a little bit, the pendulum sways opposite, and it keeps it from moving so much. So I think it's in places like Japan where they have lots of earthquakes. It's really common for their buildings to have pendulums on top to offset the movement. So pendulums are pretty important in architecture and mechanical engineering, and they model geometric sequences. So they're pretty cool. So it says this is a pendulum swing. It's a tiny little one, not a huge one. So when it swings each time, it decreases a little bit. So the numbers are going down, 6, 25, 500, 400. Write a function that represents the distance the pendulum swings on its swing. So yesterday we talked about this formula, A1 times R to the n minus 1. So we need to find R. And I only did one example yesterday, and it was kind of easy to see what R was. It was 4. But I don't have as much luck figuring R out when the numbers go down like this. It doesn't just jump out at me. So I'm going to have to set up fractions. Or we'll just go ahead and call them ratios, because that's what R stands for, is ratios. So I'm going to do 500 over 625, and I do 400 over 500. So you do the second term over the first term. And then you can reduce that, and that'll give you the R value. Second term over first term. So this one's kind of easy to simplify. Like these zeros just move out. And this R value is 4/5. And this one, I might just grab a calculator, hit the fraction button, type in 500 over 625. And hit enter, and it'll simplify it for you. And it is also 4/5. So this means our R value is 4 over 5, which is 0.8. So if anybody used 0.8, that's okay, but there's actually, this is gonna show you kind of a cool application, a cool algebra process. So the fraction is actually better than the decimal here. Problem works out really nicely. Okay, so this means our equation's gonna be 625 in the A1 spot. It's the first value. We use the product dot, not a plus sign. Product dot, multiplication. I'm going to use parentheses around this fraction. And my exponent is n minus 1. So this is the answer to letter A. So letter B says, on which swing is the distance 256 millimeters? We could very logically just multiply 400 by 4/5 to get an answer. And then that answer by 4/5 and that answer, we could just like extend the table, like keep the pattern going. But I'm going to show you the algebra to it. So I'm going to set the equation equal to 256. And solve it this way using the opposite operation. So I'm trying to figure out this n, which is an exponent. We need to know what the exponent is because this is an exponential relationship in geometric sequence. So I'm going to divide both sides by 625. And I'm going to leave it in fraction form. Like that. And I'm going to put just a little glue here before I go on. I want you to try to create this. I want you to try to create the same base, which is something we practiced in our exponential equation chapter. So you can rewrite 256 over 625 so that it looks like 4/5. So I'm going to pause and let you guys try to problem solve that before I just go any further. Okay, do you see a student use a logarithm to find an exponent? You could use a logarithm here. There's another way, but a logarithm is possible. If you want, you can try using a logarithm. But there's another way. Anybody figured out how to create the same base on the left and right? I recognize something in the number 256. 256 is a power of 4. It's 4 to what power? Try with my calculator. It's a good little review. 4 to the 5th. It's 4 to the 4th. So I'm going to rewrite 256 as 4 to the 4th. 625 is also a power of something. It's a power of 5. 5 to what power? 625. It's not the 3rd, right? The 4th. Look at that. They kind of set this problem up. Really cool to review this process. Okay, so I can rewrite 256 as 4 to the 4th and 625 as 5 to the 4th. It's okay if you didn't recognize that. You will as you move on. Math, you'll see it more and more. And so this is what it looks like to create the same base. So I can take that exponent of 4, put it out here, and now we have the same base on the left and right. We haven't done that in a long time. I think it's chapter 7. Actually, I don't remember. Okay. So once you have the same base, you can drop the base and equate exponents. So 4 equals n minus 1. Add 1 to both sides. And 5 equals n. So I'm going to say on the fifth swing, I'm just going to shorten it and say the distance is 256 millimeters. So on the arithmetic sequences, I kept saying, well, this is slope, rise over rise, linear. And that pattern was very easy for you because you've been working with it since pre-algebra. Now, a geometric sequence is going to utilize all the skills that you learned with exponential equations that are less familiar to you. But exponential equations are equating same base and using logarithms. So those types of properties apply to geometric patterns. So it's a really cool application. So if you want to get out yesterday's assignment, I'll put the answers up and you can check your work, ask questions. So there's some like really neat videos on YouTube about these pendulums. This is in Taiwan. Looks like the biggest one. How Taiwan's building survived an earthquake is a pretty cool headline. There's a huge pendulum in the middle of this building that saved it during an earthquake. The power of wavelengths is really interesting. So let's see how many are in the US. We don't have as many earthquakes as a lot of other countries. We're really lucky. This is okay. I'm not going to take up any more of your time, but the pendulum, when the ground begins to sway, so like if the building starts swaying this way, the pendulum isn't attached to the ground. It's like a ball sitting here. The building sways, the pendulum doesn't move because this hinge is like, it's really like no friction. So the ball stays in place while the building goes. And the weight of that ball stops the building from going so far. And so then the building will come back this way, and then the pendulum will start moving, and it actually moves opposite of how the building moves, and they balance each other out. It's really cool. I like it because it's such like a, it's just gravity. It's just using gravity really well, you know? So it doesn't, you don't have to know programming or AI or anything like that to understand that, like physics and engineering. So I guess that's why I like it. Okay. Here's your answers to 23 through 30. So you know today's assignment is just through it. It's 9-2, number 1 through 22. So you're doing the first part of the assignment today. I'm sorry, 9-3. What page is 9-3? Anybody? Thank you. 852, right? Yeah. Okay. You're doing 1 through 22 today, and so are any of these, you guys might know better than me at this very moment, which was the most difficult problem to figure out? Or did anybody really have a hard time figuring out the R value? I know that can be tricky. This 0.1 was probably difficult. The negatives were probably difficult. Does anybody want to ask about one of these? Okay, well let me know as you're checking. Yes. You put a what? Okay, that's okay. I think that it's okay to use decimals here to get through it. All right, I'm gonna start my journey around the room grading chapter 9's work. So I'm gonna ask to see 9-1, 9-2, and this assignment. And you can just say, this is Bosman, I don't have it ready yet. I haven't been here. That's okay. Or you can say, yeah, here it is, get it over with, move on with your life. Starts with 9-1 through 3.1, then 11 through 21, then 21 through 28, and then 1 through 20 follows. Oh, no, nothing. Okay. Alright, what do you have down on section 9? If you're not sure what you should work on, let me know. Oh, great. Yeah. Yeah. And now we're on the next one. Run. Okay, get it all done. And then you switch it. There we go. You're done. You're all set up. Very good. So if you want to do these, 4 points. Okay, got it. All right. In there, 9:30. Very good. Yeah. Okay. Thank you. Good. All right. Not yesterday. Okay. Just let me know if you get it done.